Hello, and I want to welcome you to a discussion on rationalizing the denominator of rational expressions. So, what we need to look at are these rules. For a fraction containing square roots to be considered simplified, there must be no square roots in the denominator. To rationalize the denominator means to multiply both the numerator and the denominator by the square root that appears in the denominator. To rationalize denominators using conjugates means to multiply both the numerator and denominator by the conjugate of the denominator. Conjugates are, you could say, A plus B, and its conjugate would be A minus B. So you just replace the signs in the middle spot. Looking at an example, notice this is not simplified because we have a square root in the bottom. So to get rid of that, what you want to do is multiply by 1 in the form of something over itself. In this case, you want to multiply by the denominator over itself. So we could write that as multiplying it by the square root of 3 over the square root of 3, which we know is just multiplying it by 1. And if we simplify this, on top we'll have the square root of 11 times the square root of 3 over the square root of 3 times the square root of 3. What happens on top? You get the square root of 11 times 3. And on bottom you have the square root of 3 times 3. To carry this out, we have the square root of 33 on top because that's 11 times 3. And on bottom we have square root of 9. We can simplify this as the square root of 33. On top and on bottom we know that 9 is a perfect square, so it can come out with a radical as 3. With number 2, what we first want to do is break this into 8. With a fraction with a numerator and denominator each having radicals. We break this into square root of 2 over the square root of 11. All we did was take the square root of the fraction 2 over 11 and break it into 2 different pieces. Now we're able to multiply by the form of 1 of the square root of 11 over the square root of 11. Alrighty, so we're just multiplying by the form of 1 of square root of 11 over the square root of 11. So on top, that we can break that into the square root of 2 times the square root of 11. Just as on the bottom, we can simplify it as square root of 11 times the square root of 11. Okay, on top, we're going to have the square root of 2 times 11 inside the radical. And on bottom, we're going to have the square root of 11 times 11. Okay, so on top we'll have the square root of 22 over the square root of 121. We can note that 121 is a perfect square, so it can come out of the radical as 11. That is our final answer. That is a simplified expression. With our next example, we're actually going to need to use the conjugates. So to do that, again, we're going to multiply by 1, and on top and bottom, we'll write our expression, but instead of having the middle term as a positive, we're just going to rewrite it as a negative. Okay, so that's going to leave us with, on top, 2 times the quantity, 1, minus the square root of 3. With on bottom, we're going to have 1 plus the square root of 3 as quantity, times the quantity, 1 minus square root of 3. So now we need to use the distributive property on top with 2 times 1 plus 2 times negative radical 3. And on bottom, we'll use the FOIL method to distribute the 1 to both pieces in the second part of parentheses, and the radical 3 to distribute across everything as well. So we'll start off with 1 times 1 plus 1 times a negative radical 3 plus radical 3 times 1 plus radical 3 times a negative radical 3. Let's go through and simplify. On top, we're going to be left with 2 from 2 times 1, and then we're going to have a negative 2 times radical 3 from this portion right here. And on bottom, we see this is going to become 1, and this portion right here, because it's just going to be left with 1 times negative radical 3 is negative radical 3. Times, and this is actually a positive radical 3 right here. So these cancel out going to 0. And right here we see we're going to have a negative 3. So we're going to have 2 minus 2 radical 3 over 1 minus 3, or just negative 2. We can actually simplify this into the problem, because there's a 2 in each part of the term, so we'll have a negative 1 plus 1 radical 3. For our final example, using conjugates, we're going to multiply the denominator on top and bottom, rewriting our problem originally, but replacing the middle term with a positive instead of a negative. Now, let's rewrite the terms as radical 7 plus 5 times radical 7 plus 3. And on bottom, radical 7 minus 3 is a quantity times quantity radical 7 plus 3. Now if we go through and simplify using the FOIL method, we'll take this first term, multiply it by everything in the second set of parentheses. This will work with the 5 distributed across. When we do, we'll have the square root of 7 times the square root of 7 plus the square root of 7 times 3 plus 5 times the square root of 7 plus 5 times 3. And that's all going to be over using the distributive property for the first term on bottom to get it across everything in the second set of parentheses. This will take the negative 3 and distribute it across everything as well. When you do that, we're going to have the square root of 7 times the square root of 7 plus the square root of 7 times 3 minus 3 times the square root of 7 minus 3 times 3. Now let's go through and simplify. Square root of 7 times the square root of 7 is just 7. 3 times square root of 7 is 3 square root of 7. 5 times the square root of 7 is just 5 square root of 7. And finally, 5 times 3 is 15. And that's all going to be over. Square root of 7 times square root of 7 leaves you with just 7. We're going to have 3 times square root of 7 is 3 square root of 7. Negative 3 times square root of 7 is negative 3 square root of 7. And a minus times a positive is a minus. 3 times 3 is 9. If you see these right here, we'll go to 0. So we're going to be left with, on top, we can combine the 7 and the 15 together to be 22. And if you look, these both have the common terms of radical 7, so we combine those to be a positive 8 square root of 7 divided by, and we have 7 minus 9, or just negative 2. And we can actually again simplify this, because each are divisible by 2. We'll be left with a negative 11 for the first term minus 4 square root of 7 for the second